When you go and do an investigation, you typically start with condition assessment, right? This might be a visual survey, localized sounding, or crack mapping, with the idea of trying to get an overall feel for what's happening. Depending on what you find, you then can determine what, if any, further evaluation is needed. These additional investigation methods could be things like non-destructive testing techniques, might be semi-destructive with small core samples, or it could be invasive, removal of large samples or openings in the structure itself. Now, depending on what you're trying to solve and the constraints, you might usually select a combination of these above methods to help answer it. With that, I'm going to hand it over to Linda to talk about some of the non-destructive approaches that you could use in the field.
Now, as Brett was saying, there are many reasons we might want to go out into the field in order to assess the concrete structure. In particular, we're going to go out and talk with people who are actually at the site in order to see what they're seeing. We're looking all over for signs of distress, such as cracks, falling, and efflorescence, things that show that the concrete probably is experiencing something in that area. And seeing these visual signs of distress, as Brett said, these are just symptoms. We want to start to get to know what that distress might actually look like. One of the first ways we're going to do this is through a technique called sounding. We're going to take a hammer, such as this one, and go to the concrete where we possibly see distress and expect there to be an issue. And we're going to hit it. Bad concrete, or concrete that has distress present, is going to sound more hollow than concrete that doesn't have deterioration present. One of the more common signs of distress that we're going to find with the sounding technique is delamination, or when layers of the concrete have started to separate. Ultimately, our visual inspection and our sounding help inform where further non-destructive or destructive techniques might be required in order to understand what's going on in the concrete. One of the more common ways that we'll do this is with ground penetrating radar, or GPR. In ground penetrating radar, the radar is going to come out through an antenna and go into the substrate, in our case, concrete. Now, that radar signal is reflected back, and materials with different dielectric constants will appear as different colors on our data collection screen. We're simply going to run the GPR unit along the concrete in order to pick up on the signal. As we go laterally, the wheels are marking where along the slab we are, and so we have a calibrated data set that shows us the distance along our scan. When we look at the data, we're going to see all of these different colors representing different parts inside of the slab. The brighter parabola shapes are going to be where the reinforcement is, so we can use this in order to direct coring operations, possibly in order to make sure that we don't hit the reinforcement when we're going through. But there's also some information that we can't just get from the handy scan unit. We have several different antennas that we can attach to the unit in order to emphasize different features that we're interested in. So antennas of different frequencies might have better lateral resolution, but worse depth resolution, or vice versa. With the larger GPR unit, we're able to collect data that we can take back into the lab and start to analyze. We want to start to process the data in order to better understand some of the features that we see. So now the rebar has been condensed down to little points, which allow us to reduce the noise. So you can see that this scan is a lot less noisy than the previous scan was. And it allows us to pick up on other features such as subslab voids. So now, by doing these scans across an entire area along a grid along the slab, we're able to laterally map the extent and approximate depth of deterioration. So if we see evidence of deterioration, we might take another non-destructive test out with us, such as impulse response. And this will allow us to see if there are any structural implications for the deterioration that we're seeing. Or if we're trying to understand what the size of the underslab voids is, we might go and take a core in order to peek under there in order to calibrate what we're seeing in the GPR.